Hello world and universe. I'm Jay Sherm, and in today's episode of Future Tech, I want to talk about why space telescopes are so important for not only space exploration, but for the future of mankind. You may have heard in the news recently that NASA recently launched the James Webb Space Telescope. Maybe you don't even know what it is or why it's important, but I'm sure everyone has heard of the Hubble telescope. It's been in orbit around Earth for decades now, giving us images and glimpses of the universe going back millions of years. But there are some clear differences between the Hubble Space Telescope and the James Webb Telescope, and that's what I want to cover today. The first thing I want to mention is I do hear people saying that the James Webb Telescope is a replacement for Hubble, and that's just not the case. If anything, it is the next evolution of the Hubble because it is going to be seeing much further away, much further in the past. And there's a clear difference in terms of what type of imaging sensors and instruments that will be on board to see the galaxies that are far, far away. One of the clear differences in the Webb telescope is the size difference. It is about 6 times the size of the Hubble. When it is fully opened, because it's going to be now opened during stages, there are 5 sun shields and then a large mirror made up of gold, smaller mirrors. It's going to take some time to open it up, and it's still traveling to its destination as I speak right now, which is pretty cool. There's actually a website online you can look up where is James Webb Telescope, and it'll show you exactly where it is right now. So that's pretty cool. I recommend checking that out. But when it's fully opened up, it'll be the size of a tennis court. And if anybody has ever been on a tennis court or seen a tennis court, you know they're pretty big. One of the biggest differences that I noticed when checking out the James Webb Telescope is that its main function is to see in infrared light, whereas the Hubble Space Telescope is mostly UV and normal viewing, so you can basically see imagery. James Webb's going to be looking at infrared light, which is a different spectrum. And although the Hubble can see in infrared, it can only see it in a minimal amount. And I'm not going to get into the technical details, but let's just say James Webb is specifically built for infrared. And you may be asking, well, why is that important? Well, just like our houses and the world, there is dust everywhere in space too. Space dust, galactic dust, interstellar dust, whatever you want to call it. And it could be, large dust particles, small dust particles, asteroids, cloudy fields of interstellar, material. And this blocks the view of traditional telescopes. And if you look at Hubble imagery, you'll see, these large clouds, right? And you can't really see the stars and the planets within those clouds. But the James Webb Telescope, its function is to basically see through all those clouds to let you see all the stars and the planets. And this is huge. Here's why. The first thing is, we don't really know how stars are formed. Sure, we know that everything is made of stardust, even us, humans, we are made of stardust, but we don't know how they're formed, and we can't see that with the Hubble. What the James Webb promises is to be able to see a star form. So by seeing through these clouds or these nebula, which what they're called, we'll be able to take a glimpse at galaxies that we were never able to see before. And when it comes to things we weren't able to see before, NASA has been studying far off galaxies millions of miles away for decades. They've been using the Hubble telescope to see what they can see, but the truth is they've been discovering planets and star systems and galaxies far away, but they haven't been able to really look at them. So what I'm understanding here is that not only will they be able to now see galaxies, stars, and planets that are far away, but they're going to be able to investigate the ones they've discovered in all these decades, but they haven't been able to see. So this is going to open up a whole new wave of space exploration, possibly finding life out there. If we're going to find life, this is the way we're going to do it. So definitely follow the James Webb Telescope on Twitter and any articles you read, because this is going to open up a lot of amazing discoveries. Another interesting fact about the James Webb Telescope, as I mentioned, the Hubble is orbiting Earth, right? That's where it is. It's able to be serviced by the space shuttle and any astronauts that are able to work on it to fix any broken parts. But James Webb is not orbiting Earth. It's actually, like I mentioned, it's on its way to what's called the second Lagrange point, or L2. There are several Lagrange points that are around the sun or in different parts of our galaxy. And by being near the sun, it's going to be getting a lot of heat, obviously, but that's why there's 5 sun shields to protect. And then the opposite side is where all the mirrors are that can see the light from far distant galaxies. And that side is very cold. So scientists and engineers had to figure out a way to build this massive telescope that was able to protect itself from the heat on the back, but be freezing from the front to capture that heat signature, the infrared light, from very far away. And they were able to successfully do this over the course of decades. I mean, they've been working on this telescope for decades. I believe from the 90s they started working on it. And then in the 2000s and the aughts, they had a lot of problems, a lot of failures. So one thing you have to remember is scientists, engineers, and astrophysicists and whatnot, they've been working on this their entire careers, not just a couple months, not just a couple years. Some people have been working on this for 2 decades or more. So I can tell you right now, there are a lot of happy people out there watching this thing get to its destination at L2. When it does reach this 1,000,000-mile destination, it's going to just sit there and it's going to be orbiting the sun, not the Earth. So that's the other difference. Hubble is orbiting Earth. Webb is going to be orbiting the sun, and it's going to have a pretty much fixed point. It's not going to be moving around. It does have fuel on board, I believe, for 10 years to allow it to hit some thrusters if it needs to reposition itself. But I believe it's mostly going to be just in a fixed location. And while we won't be able to see the telescope because it's too far away, unless maybe the Hubble can send us some pictures of it, I don't know, I guess we'll find out. Imagine a tennis court in space facing space, and behind it, its butt, is the moon, the Earth, and the sun. And it's the 5 sun shields are blocking all the light that's coming from the Earth, the moon, and the sun. And in front of it, it's just cold space. That's the James Webb Telescope. And so all the infrared heat signatures from distant galaxies and planets and stars are going to be coming toward it from millions of miles away, and it's going to be able to see them. Which means we will be able to see back in time. And that's the goal here. The goal is for humanity, for astronomers, for NASA, for people to be able to take a glimpse back in time to the possible formation of the Big Bang, the formation of the universe. Where did galaxies come from? Where did planets come from? Where did stars come from? We will be able to see back in time, because when the light reaches us from, say, a galaxy that's 20 million light years away, just as I don't even know how far away that is, but let's just say it's 100 million light years away. It's taking 100 million light years for that source of light to reach the James Webb Telescope. So essentially, we're looking back in time 100 million years. Because as we all know, maybe you don't, it takes about 8 minutes for the sun's light or heat to reach us, right? So when you're looking up at the sun and you see the light, it's taking 8 minutes for it to travel from the sun to the Earth. Same goes for another sun or another star or another planet that's 100 million light years away. It's taking that long for it to reach us because the light has to travel through space. So we should be able to see back in time, quite far back in time. And Scientists and engineers and astrophysicists and everybody who's working on this project, their goal is to look at the data, look at the infrared images, look at all the instrumentations, data that's coming through the telescope to tell us where we came from. And that's a very important question. Where we came from, and are we alone? And I believe with the James Webb Telescope, we're going to find out. I want to hear how excited you are about it. Tell me what you think we're going to find in the comments. You have any questions or feedback, or are you curious about other things the telescope can do? Leave it in the comments. I always respond. I appreciate you watching, and don't forget to tune in next week's episode.